Today's lesson, we are going to talk about arc length and areas of sectors. All right. So, fortunately for you, because I always do this, I'm such a nice guy sometimes. I've got them. There they are. There's the formulas for you right there, huh? You didn't get one, I bet, huh, Stephanie? Is that what you're trying to say?
Yeah.
All right, Stephanie. I think I got an extra sitting right here. Come on up and grab. Come on up and grab. Stephanie. Right in the middle recording, girl. You got to tell me beforehand. There you go. Gotcha. All right, so back to the live version of recording. Okay, so arc length. So arc length, I've got theta over 360 times 2 pi, but again, we changed that. We changed that to theta over 180 times pi and r. Okay, we modified that, right? Guys, stop talking. I'm recording. Okay, there you go. That's the better version of it, right? So, if you want the area of the segment, and the segment is the crust, all right? So, the segment is just the piece. In fact, I'll draw a little picture over here so we can see what the segment is. Again, you've got a circle, you've got an angle. The segment is the crust. I guess that's the easiest way. Like a piece of pie, it's just the crust, right? So how do you do all these? Actually, it's not too bad as long as you have a formula. We do have a formula. So first of all, in example 1, we have a formula. So it says find a circle has a central angle of 40 degrees and a radius of 3. Find the arc length and area of the sector. So I'm just going to draw a picture because it's, you know. So I'm going to draw a picture. I'm going to estimate 40 degrees. I could use my protractor, I suppose, if I really want to get fancy, but I'm just going to guesstimate 40 degrees. It looks like it could be about there. So about 40 degrees. Okay, so first of all, let's talk about the arc length, okay? So the arc length is really a length. It's, if I were to put a piece of string and lay it on this circle, and take that string then and stretch it out tight and actually measure it. How long is this? It's a length, right? So to find the arc length itself, because it's pretty hard to measure a circle because it's like, you know, right? A formula is going to do it for me. So my arc length formula is this theta. So arc length is going to be this formula, theta over 180 times pi r, okay? It's pretty easy. I know the radius is 3. I know the angle is 40. I'm just going to plug it in. So my answer is going to be, well, let's put the 40 in for the theta over 180. So I'm just putting my 40 right there times pi times my radius, which is 3. And I'm just going to use a calculator. Now you can keep things in terms of pi, which is great. I'm not going to, only because for a practical problem, you'd want an actual length, right? So I'm just going to go ahead and do this. I don't mind answers in pi. I kind of like them in answers of pi, but so I'm just going to go 40 divided by 180. I'm going to multiply that times pi and then times 3, and I can answer about 2.09, and that'd be in terms of centimeters. Not centimeters squared because it's the actual length, right? Just plain old centimeters, okay? Okay, that's going to be the arc length. Okay, that's how long that piece is. Now the next thing we have to find is the area of the sectors. The area of the sector is like just, you know, how much pi do we get to eat, right? What's the area of that wedge? Again, I have a formula. So the sector, the area of my sector, I have a formula. It's going to be my theta over 360 times pi times the radius squared. I'm just going to plug the numbers in. Okay, so we'll put 40 in for theta, right? Over 360 times pi times 3 squared. So we'll go, all right, 40 over 360 pi times the radius squared, which is 3 squared. And again, I could get things in terms of pi, which is great, but I'm actually going to get an answer, so I get it something that can be used. So I'm going to go, okay, parentheses, I'm going to go 40 divided by 360 times pi times 3 squared, which is 9, right?
Bless you.
Thank you. So I have about 3.14, so obviously must have reduced all the way to pi. So I get an answer about 3.14, and that would be in terms of centimeters squared, because it's an area, okay? Not too bad. Thank you. It's that time of year. Okay, example 2. Example 2 takes a little bit more work. To find the area of the segment, okay? Take a look at our notes real quick. Let's slide it up. So the area of a segment is going to be the sector minus the area of the triangle, okay? So we're going to put that on there. So what we need to do is find the sector, which is like the piece of pie or the wedge, right? And we're going to subtract the triangle. So if we take the piece of pie, right, and we subtract out that triangle, what's left over is the crust. Well, let's use the math words. If you take the sector minus the triangle, you get the segment. Or, easier, take the piece of pie, subtract the triangle, and you get the crust. How's that? Easy to understand, right? So the sector, we already have a formula for that. And that's going to be our theta over 360 times pi r squared, right? And then a triangle, we know the area of triangle. A triangle is just going to be 1/2 base times height, right? So, all right, let's do this. So, right off the bat, that's 90, right? So, I go 90 over 360, because that's my theta, right? 90 degrees, right there, times pi, times the radius, which is 4. So, I'm going to go times 4 squared, okay? And I'm going to do that in my calculator, okay? So, what is that answer? Actually, I can put a whole thing in my calculator, but I'll do it real quick. Okay, 90 divided by 360 times pi times 4 squared, which is 16. So I get an answer about 12.566, okay? Now, the triangle, that's easy, because the height of the triangle's got to be 4. Agreed? And the triangle's got to be 4 because, I mean, it's a circle, right? So the radius is equal. So we'll just go 1/2 base, which is 4, times the height, which is also 4, right? So half of 16 is 8. So if I subtract these two, minus my 8, I get an answer about 4.566 centimeters squared, because it is area. I mean, it's the area of the crust or the segment, okay? Not too bad. Thumbs up. Okay, thumbs up. I mean, it isn't that bad at all, is it? It just makes sense what we're doing. Okay, turn the page whenever you're ready. I will certainly wait for you, okay? Okay, ready? Turn the page. Alright, now, this one's a little bit different, but the same type of problem, okay? Find the area of the sector, okay? So, again, if we look at our notes for part A, my sector, we know the formula is theta over 360 pi r squared. And I just got that from the notes, okay? And I just happen to know these formulas because I've been doing this forever, right? But so that's the formula, right? We can go ahead and turn over the paper. There it is, right? So I'm just using that formula, okay? So let's just plug in our numbers and get it. All right, this is easy, right? So my answer is going to be, well, let's see, 60 over 360 pi r squared. I'm just going to use my calculator, right? Clear that. I'm going to go 60 divided by 360 times pi times, let's see, what's the radius? 12 squared, right? So I get an answer about 75.4, okay? So to say 75.4 centimeters squared. Okay, so far so good. Area of the arc length. Well, I can do that. Again, what's my formula for the arc length? Look at, oh, there it is right there. Okay, so I've got my arc length formula. So my arc length is going to be just my theta over 180 times pi r. That's the formula we got in our notes, right? So we're just going to plug the numbers in. That's easy. So we're going to go 60 over 180 pi times 12, okay? I'll let you catch up and write those down, okay? And these are the formulas we have in our notes. Just going to plug them in, hit my calculator, get an answer. All right, let's see what I got. So I use my calculator. I'm going to go clear, slide that over so you can see it. 60 divided by 180 times pi times 12, and I get an answer about 12.56, okay? So I get about 12.56 centimeters, okay? How am I doing? Pretty easy. I mean, it's just using a form, okay? Now, the area of the triangle. Now, we're getting pretty good at this. I'll tell you why. Because if I take a look at this triangle, and I'm going to draw it, I'm going to superimpose it, okay? 12, 60. I know a couple of things about this triangle. I do. This is also 12, right? Okay, and so if this is 12 and that's 12, then these two angles are equal, so it turns out to be 12, 12, 60, 60, 60. Agree with that? Right? And then if I want to find the area of the triangle, I need to go 1/2 base times height. So the base is 12, but what's the height? That's easy, right? We know how to do this, right? We cut it right down the middle. We're getting good at this 30, 60, 90 triangle, aren't we? Katie's right. Everybody agree with Katie? 6 squared is 3. Remember when that was hard? Now that's so easy to do, isn't it, right? So then the area of this triangle is going to be simply 1/2 base, which is 12, times the height, which is 6 squared is 3. I'm just going to use my calculator to get that answer, okay? So we're just going to slide that over and go 0.5 times 12 times 6 square roots of 3, and I get an answer of about 62.35, okay? 62.35. How am I doing? And that's in terms of centimeters squared, okay? So then finally, if I want the segment, that's easy. I can get the segment pretty easily because the segment, squeeze that over here, is equal to the wedge or the sector minus the triangle, which I have both of those. I just have to put the numbers in, right? So if I want to find the segment, it's going to be the sector. Well, the sector we found out was 75.4, right? It's right there. Minus the triangle, which we just found here. It's minus my 62.35. Just going to use my calculator. Let's see, 75.4. Subtract that. Get an answer about 13. About 13. And that's be centimeters squared also because it's area, okay? How's that? Okay, not bad, is it? So homework today, and it is a Friday. I'm giving you lots and lots of times to get it done. Lots of time, so you may play on your phone when the homework's done, huh?